All right, performing function operations and composition of functions. I'm going to throw some domain stuff in here on this video also, so you got to really pay attention to this one, take some good notes. All right, operations on functions. First of all, we're going to take two functions and we're going to add them together, subtract them, multiply and divide them. So basically taking f of x plus g of x, f of x minus g of x, f of x times g of x, and f of x divided by g of x. There's examples over here where you have f of x is x 5x, g of x is x plus 2, and you can see right here when you add them, you just literally add the two functions together. When you subtract them, you just subtract them, multiply, kind of distribute that 5x and multiply. Then when you divide, you just put function f over function g. Now, this is the big deal. The domain of the final of h of x, which is after you combine them, are the domains of both. So what they have in common, it will be the domain of your final function after you do your operation. Let me show you a couple examples here. This one says f of x is 4x to the 1/2 and g of x is negative 9x to the 1/2. Find the following. Part A says f of x plus g of x. You would just take 4x to the 1/2 and add it to negative 9x to the 1/2, which would be negative 5x to the 1/2. And that's all you got to do. When you subtract them, the same thing. 4x to the 1/2 minus negative x to the 9x to the 1/2, which means you would get 13x to the 1/2. All right, in part C, the domains of f plus g and f minus g. Now, the domain of function f, remember, 1/2 power really means square root. And because it's a square root, you cannot have a negative number inside there. So my domain for this one would be x has to be greater than or equal to 0. Same thing on this one. So when you do the domain for f plus g, it's what they have in common. Well, they're both the same. So the domain would be x has to be greater than or equal to 0. For f minus g, the same thing is true. It's what they have in common, which is they're the same. So it's just x is greater than or equal to 0. So they're going to ask you to do all of that today, add them, subtract them, and find the domains. Right now, they're going to ask you to do two more things. They're going to ask you to multiply them, divide them, and find the domains again. So I'm basically taking, when I multiply, I'm taking the 6x and multiplying it times x to the 3/4. When you do that, remember you add exponents. That's really x to the first power, which is really 4/4. If you add 4/4 and 3/4, you get 7/4. So that's where that's coming from. The second one, 6x over x to the 3/4. And again, when you divide, you subtract exponents. That's a 1 up there, so I'm doing 1 minus 3/4, which is 1/4. And then part C, they're going to ask us for the domain. When they ask you for domain, again, when you do an operation, it's what they have in common. This first one right here is x can be anything, so it's all real numbers. X could be anything at all. On the second one, it's really this. It's really the 4th root of x cubed. Remember, bottom is the power, top is the root. And because it's the 4th root, you have to have a positive number in there, so x has to be positive. So I'm looking for what they have in common. This has all real numbers. This is x is greater than or equal to 0. It can be anything. So what that means is, for this one, I'm going to have to say x is greater than or equal to 0. That would be my domain, or all non-negative numbers. Now the second one, a little bit different because actually I haven't said this yet, but when you do the domain, you need to look at right when you first set it up. When you first set it up right there, instead of looking at your final answer. So right here, still is what they have in common of these two, but I have to do one more thing because you can't have a 0 in your denominator. So in this one, my domain would actually be x is greater than 0 instead of greater than or equal to 0, because I actually have an x in my denominator, and you cannot have 0 in your denominator. Hope that made some sense. Okay, second half today is called composition of functions. When you composition of functions, you're really kind of combining two functions is the best way. You're going to see it written like this a lot: g of f of x or f of g of x, or even sometimes today you may see f of x, which means what you're going to do is you're going to take one function, plug it into the other one. Take this function, plug it into that one. It can also be written like this. You'll see this a lot. If you see that, that is the same thing as this, as f of g of x, okay, called composition, where you're going to plug function g into function f. And I'll show you that on the next slide exactly how that works. Now, the domain of this is a little bit different. What we're going to do for the domain of composition of functions is we're going to take the domain of the inside one, which is this one, with the g here. We're going to take that domain, and then we're gonna set it aside for a second. Then we're gonna actually plug the function into the other function, look at what we get as a final answer, and then we're gonna find the domain of that, and then we're gonna kind of combine them both. We're not gonna see what they have in common. We're gonna actually use both parts to get our domain for that. Let me show you one example and see if it makes some sense. Okay, this one says f of x is 4x to negative 1. G of x is 5x plus 2. Now the first thing it's asking me to do is to do f of g of x. So I'm going to take g of x and plug it into f of x right there. So f of g of x is going to look like this. I'm going to plug the 5x minus 2 into the x in f. So I'm plugging function g into f. So it's going to look like 4 times 5x minus 2 to the negative 1 power. Now, remember, negative exponent means you flip things, so it's going to be 4 over 5x minus 2. And that's how you do the composition. Okay, look at the second part here. Let me change colors. Okay, second part says g of f of x, which means I'm going to take f of x and plug it into function g, where the x is. So it's going to look like 5 times 4x to the negative 1 minus 2. If you multiply that out, you're going to get 20 x to the negative 1 minus 2. Remember, the negative exponent flips things, so you get 20 over x minus 2. And that's the second one. Now the third one is kind of an unusual one. It says f of x. You're actually going to take f of x and plug it into f of x, kind of plugging in at itself. So I'm going to take the 4x to the negative 1 and actually put it into the x right there. So it's going to look like this. 4 times 4x to the negative 1 to the negative 1. I just put the 4x to negative 1 where the x used to be. And when I work that out, it looks like this. So it's like 4 times, remember the exponent outside goes for everything inside. So it's 4 negative 1 and it's x to the 1. So I end up having to flip that 4. Or, even better than that, instead of flipping the 4, add the exponents on the 4 when you multiply. That's 4 to the first power times 4 to the negative 1 power. That'd be 4 to the 0 power times x. Remember, anything to the 0 power is 1. So it's really 1 times x, which is x. So there's my answers when I do the composition. That is what's called composition of functions, when you're plugging one function into another one, working out as far as you could go. All right, then it says find the domain of each. So I'm going to go back to the first one here. It says find the domain of a. Well, when I did a, I'm going to find the domain of g of x first, what's inside. Well, if I'm looking at this, there's no restriction. So that is all real numbers. There's no fraction, there's no square root, so I'm good there. You can put anything in for x you want to, so there's no restrictions, all real numbers. Then I'm going to look at my final answer. My final answer, I cannot have a 0 in my denominator. So if I take my denominator and figure out what would make it equal 0, I would just set it equal to 0 and solve it, so I get 2/5. So what that tells me is x cannot be 2/5 because that would make my denominator 0, which I can't have. So my domain for the whole thing is combining the two. This is all real numbers. This is x equals 2/5. So it can't equal 2/5. So my domain on that one would just be x cannot equal 2/5, and that'd be in our domain. Any all real numbers except for 2/5. And I'll show you a good way to write that tomorrow. On the second one, going just the opposite, I'm going to the domain of f of x. Okay, the domain of f of x is really this, which means x cannot be 0. And when I get my final answer, looking right here at the red one at the bottom right here, still I can't have 0 because it would make my denominator 0. So my domain is what, combine all that, and my domain is x, any real number except for 0. You cannot have 0 there. And the last one more domain to get through here. This says f of x, so start out with your domain of the inside part. Again, we just did that a second ago. My domain on that one is x cannot equal 0. Combine that with your final thing we got here, which is x, but because I'm combining the two, x cannot equal 0 would be my domain. Any all reals except for 0, and I'm good. So one more time. The composition is not hard. The composition, you just take one function, plug it in the other one, and work it out. Take that function, plug it in there, work it out. Take that function, plug it in there, work it out. Domain, you have to find the domain of the inside part, and then the domain of your final answer, and you put everything that is a restriction. So you combine the first restriction with the last restriction. And again, we'll work on this tomorrow. I promise we'll get to where you understand it really well, but that's a good video. It'd be a great video to watch after you do the lesson so that you could really understand it really well. Just an idea there. See you tomorrow.